How does a message actually cross an entire ocean? Most people point at the sky. And almost everyone is wrong. It is not satellites. Satellites carry a tiny sliver of the world's traffic. The real internet lives underwater, in the cold and the dark. So why not just beam everything down from space? 2 reasons: capacity and lag. Bouncing your signal 22,000 miles up to orbit and back adds a delay you can actually feel, and no fleet of satellites can shift data like a cable can. And we have been laying wires under the sea for a very long time. The first cable crawled across the Atlantic back in 1858, carrying messages at a few agonizing words per minute. Today's cables carry the entire internet. Same stubborn idea, wildly upgraded. About 99% of all data that crosses an ocean travels through cables lying on the seafloor. There are more than 500 of them in service right now, crisscrossing every ocean on Earth. Laid end to end, that is roughly 1.4 million kilometers of cable. Enough to wrap around the whole planet more than 30 times. Together they form a single web, tying every continent to every other continent. A nervous system for the entire species, quietly soaking in salt water. When you load a page from another country, this is the road it actually takes. And they are absurdly fast. One fingertip-thin pair of fibers can now push hundreds of terabits per second. That is millions of video calls at once, through a piece of glass you could floss with. Which raises an obvious question. How do you send an email through 2 miles of ocean without it just getting wet and giving up? Let's follow one, from the beach on down. Start with the cable itself. Out in deep water, most of it is shockingly thin. About as thick as a garden hose. Near the coast, where anchors and fishing gear roam, it gets wrapped in steel armor and plowed down into the seabed. But out in the deep, where nothing should bother it, it simply lies there, bare, across the abyssal plain. The part doing the actual work is tiny. At the very center sit strands of ultra-pure glass, each one thinner than a single human hair. And here is the beautiful part. Your data is not electricity in here. It is light. Lasers fire pulses down the glass, flashing on and off billions of times a second. Ones and zeros, made of flashes. And it is not just one beam. Each fiber can carry dozens of separate colors of light at the same time, and every single color is its own private lane of data, stacked invisibly on top of the others. By rights that light should leak straight out the sides. It doesn't. The glass is built so the beam keeps bouncing off the inner walls and stays trapped, racing forward. Physicists call it total internal reflection. The cable calls it staying employed. But light gets tired. Over long distances the pulses fade and blur, until a 1 and a 0 start to look the same. Across a whole ocean, that would be a disaster. So every 50 to 100 kilometers, the cable hides a booster. A repeater that grabs the faint, fading signal and pumps it back up to full strength before it can die. The trick inside is gorgeous. A short coil of glass laced with a rare element called erbium. Hit it with a pump laser, and it re-energizes the weak light passing through. No decoding. No computer. Just light, making more light. But those boosters need power, in the middle of the ocean. So a copper conductor runs the entire length of the cable, feeding thousands of volts from a station on shore out to every amplifier down the line. Getting all of this onto the seafloor is its own saga. A single ship swallows thousands of kilometers of cable into giant tanks, then lays it as it sails. Sometimes for weeks. Dropping one delicate thread across the deepest places on the planet. And it goes deep. In places, the cable rests farther below the waves than Mount Everest stands above them. A single glass thread, alone in total blackness, under crushing pressure, carrying your group chat. It all comes ashore at a plain. Unmarked building called a landing station. Usually just a beige box near a beach that happens to connect an entire country to the rest of the world. Now, all of this breaks. Constantly. Somewhere on Earth a cable fails every couple of days. Around 150 to 200 faults every single year. And this is where everyone blames sharks. Yes, a shark has nibbled a cable once or twice. It made fantastic headlines. But honestly, the sharks are basically innocent. The real culprits? Fishing boats dragging their nets along the bottom, and ships dropping anchor in exactly the wrong spot. Humanity's single greatest threat to the internet is a boat that parked badly. When one snaps, a repair ship sails out, drops a grappling hook, and drags the seabed until it snags the broken cable. It hauls both ends all the way up to the surface, splices the hair-thin glass back together by hand, and lowers it gently home. It is also why the internet doesn't collapse every week. If one path dies, your data is instantly rerouted along a different cable, on a different sea floor, thousands of miles away. And you never even notice. So how fast is all of this? Light inside the glass moves at about 2/3 the speed of light in a vacuum. Fast enough that a message can cross the Atlantic and come back in the time it takes you to blink. So think about what the cloud actually is. It is not floating somewhere in the sky. Your photos, your messages, your late-night video calls, they are pulses of light, screaming through threads of glass, lying in the cold and the dark at the bottom of the sea. And it is far more fragile than it looks. Enormous fractions of the world's traffic funnel through a mere handful of narrow choke points. Places like the Red Sea near Egypt, and the Luzon Strait beside Taiwan, where dozens of cables are squeezed together. Cut a couple of cables in the wrong stretch of water, and whole countries slow to a crawl. A single dragged anchor has knocked entire nations partly offline. The mighty global internet, undone by one boat and one very bad day. So the next time somebody tells you their data is safe, way up in the cloud, you can gently correct them. It is in the ocean. It is made of glass and light. And a fish is almost certainly swimming right past it, this very second. If you enjoy finding out what is really going on under the surface of the things you use every single day, that is the entire point of this channel. Subscribe, and you will honestly never look at the cloud the same way again. Next question in the series, number 16. How does your phone charge with no cable at all? Same kind of invisible magic. No ocean required.